Okay, question 10. Just I'm simplifying, and I've got some indices here. So y to the power of 7, or 7, that's y multiplied by itself 7 times, multiplied by y to the 2 is y to the 9. How do I know that? I know that from my rule, but I also know that because it's just y to the power of 7 is simply 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7 lots of y multiplied by itself, multiplied by y multiplied by y multiplied by itself twice. So that's just y multiplied by itself 9 times. So equals y to the power of 9. Your indices law, if you want to just remember that, is y to the power of a multiplied by y to the power of b equals y to the power of a plus b. So it's y to the power of 9, which is my answer. That should be an easy mark. Y to the power of 7 divided by y to the power of 2. Again, common mistake here was to divide and get y to the power of 3.5. Let's imagine what that is. It's just y times by itself 7 times 5, 6, 7 divided by y multiplied by itself twice. Now when you've got this sort of situation with the same thing multiplied by, on the top as what you got on the bottom, you can cancel out, which means I can cancel that one with that one, that one with that one. They cancel out because if I multiply by y and then divide by y, I'd simply end up with what I had before. What if I had these 5 lots of y and then I had multiplied by y twice and then divided by y twice? I would end up with just the 5 lots of my y. So again, my answer would be y to the power of 5. And just using your indices law, y to the a divided by y to the b equals y to the a take away b. Okay, y to the 7 all to the power of 2. Now, this means that I've got y to the power of 7 and then I multiply it by itself, y to the power of 7. So let's have a look at what that means really. 1, 2, y multiplied by itself 7 times, 3, 4, 5, 6, 7, and I'm going to multiply that by itself. So I'll put that in there and I'm going to multiply that by itself. So multiply that by, it's the same thing again, isn't it? By 3, 4, 5, 6, I'm off the end, 7, which is just 14 lots of y if I counted them up. So it's y to the power of 14. And if I use my index law there, it's y to the a to the b equals y to the a b. That's a times b. Okay. Right. Okay, let's have a look at this. If y was minus 1, which answer in part A is positive? Well, this is where you need to just use what you know about square numbers and things like that. Any number to an even power is going to end up positive, right? You take a negative number, you multiply it by another negative number, your answer is positive. That's why all squares will be positive. So minus 2 squared is minus 2 times minus 2, which is 4. Positive 4. So anything raised to an even power will be positive, whereas if it's negative it will flip-flop, won't it, between positive and negative. So for example, y to the power of 5, if it was minus 1, it would be minus 1 times by minus 1, which would be 1, times by minus 1, which would be minus 1. So y to the, I'll try to explain this. If y equals minus 1, then minus 1 to the power of 1 is just minus 1 times by itself, which is 1 times, so that's minus 1. Minus 1 to the squared is minus 1 times minus 1, which is positive 1. Minus 1 cubed is minus 1 times minus 1 times minus 1. Now minus 1 times minus 1 is 1, but 1 times minus 1 is minus 1, so my answer is minus 1. Minus 1 to the power of 4 is minus 1 times minus 1 times minus 1 times minus 1. So minus 1 times minus 1 is 1, right, because of minus times 1. And then when I multiply it by minus 1 again, it goes to minus 1. But then minus 1 times by minus 1, again, it flips back over to positive 1. So, and minus 1 to the 5, it would then flip back to a negative. So it needs to be raised to an even power to be positive. So the only one that's raised to an even power is y to the 14. Okay. If y equals 0.5, which answer in part A has the greatest value? Okay. Now this one, let's think about it. If you keep multiplying things by 0.5, then your answer gets smaller and smaller. It's the same as halving it each time. So y to the 5 is like 0.5, and then half of 0.5, that's 0.25, and half of that, and you're halving 5 times. Okay. In this one, you're halving 9 times, and in this one, you're halving 14 times. So this is actually your biggest answer, because you halve it the fewest number of times. Because it's less than 1, each time I multiply it by 0.5, my answer gets smaller, but I only have to halve it 5 times for y to the power of 5, whereas I have to halve it 9 times or 14 times for these. So the greatest value would be y to the power of 5.